This topic deals with hyperbolas and truncus. So, what we're going to start off with on this is limits. A limit is basically, it's basically looking at what happens when you're very close to a point. This depends on the direction on the graph, because remember, you can have hybrid functions. So, when you have hybrid functions, remember, you can have a different type of graph from the left and to the right. Remember, they can all be broken up as well. Because of that, we need to look at what happens when you're going from a certain direction. So, as the limit goes to x squared, we all know what an x squared graph looks like. Well, let's just do a little sketch of it. Here's our x squared graph, and I forgot to put down which side we're going from. So, here's a little x squared graph. I know it's not very accurate. Okay. And we're going to go from the positive side. So what that means is we're going to go from this plus bit going down that way towards 0. As we go towards 0, well, you will notice that this actually goes towards 0. And so all you need to do is write equals to 0. However, let's look at the second one. Okay. Our second one here is the function of x. Here's our f of x. And we're going to go from either positive or negative, depending on what I write. So, the first one we're going from the positive, which means we're going towards 0 from the positive side, from there. Well, if you ever look, the other graph doesn't actually have a positive part, and so if you follow that blue arrow, we're actually going to reach 4. So if we take the limit going from the right side, you reach 4. Okay, now you don't actually reach 4, you say you're going towards 4. Because you're going towards 4, well, you're never actually hitting the point. I know, it sounds a little dodgy. Anyway, if we're going from 0, negative now, have a look at the second one. On the top, it tells you whether or not it's positive or negative. If it says minus, that means it's negative. And so we're going to go from a negative going down that way. And if you follow that, we get to 2. Okay. So, this arrow right here, for each one of these, tells you what number it's going to go towards. Okay, and what value we're going to hit. So, you need to understand what this arrow means. It's just a very brief analysis, you don't need to know it in full detail yet. Okay, but this concept will come up later, so I figured I may as well mention it first. So the first type of graph is a hyperbola. Notice that we have a shape on the right. We'll just do a little analysis on what happens. So, if we're going by what we just did, as x goes towards 0 from the positive side, well, if you follow the x, it's going from 0 going that way. Okay. As it goes towards 0 from the positive side, notice that it's getting bigger and bigger, and so we can say that y is going to go towards infinity. As x is going towards infinity, however, which is that bit, okay, notice that it's going to the right, and it's going to get smaller and smaller. And that means y will be going towards 0. I'm going to say going towards for a certain reason. You'll see a little later. As x is going towards 0 from the negative side, so this little bit, notice that y is getting smaller and smaller. And so y is going towards negative infinity. Okay? And then, whoops, I messed up my numbers. That should be 4, and that should be 3. Okay, back to this. As x is approaching negative infinity, well, notice that y is getting smaller, so y is going towards 0. So, what do we learn from this then? Well, we can't physically put in one on 0 and one on infinity. That just doesn't make sense. So, if you look back on the graph, because it doesn't actually hit it, we never actually put it touching to the point. And so, there are these lines in which they will never actually reach, okay? And I can do any type of shift I like. And because I do any shift I like, well, they're going to form lines in which numbers can never reach. Okay, so, these lines, we're going to call them asymptotes. Asymptotes. And these are lines in which a graph will never touch. So, x equals 0 is right there. In fact, it's a y-axis for this. Well, it's always a y-axis. But, because x is equal to 0 on that line, okay, we don't put y-axis purely because you have to remember that we're going to shift it, so it's not always going to be on the y-axis, so we take the x values. Okay, x equals 0 is then called an asymptote. But more than that, because it's a straight line running from top to bottom, we're going to call it a vertical asymptote. Y equals 0 does the same thing. Y equals 0 would then be our x-axis. Because it's running from left to right, we're going to call it a horizontal asymptote. Whoops. These are usually represented with dotted lines. And there it is. So, as a general equation, we have y equals to a on x minus b plus c. As per usual, that is our dilation, that is our horizontal shift, and that is our vertical shift. And we have two different asymptotes. Okay. Notice that this little bit can't be equal to 0. Because that can't be equal to 0, we then have an asymptote, which is when that's equal to 0. So if you put x minus 2 equals to 0, then we have an asymptote of x equals to b. If you look back on the slide before, that is a vertical asymptote. Okay? And because this fraction here, okay, can't be equal to 0, well, that can't be equal to 0, and so y can never equal to c. So our other asymptote is y equals to c. So let's try and sketch this using an example. Let's just write down our a's, b's, and c's here. So we have the top bit of a fraction, which is our a. So our a is equal to 1. Our b is a split, which is equal to 2. And our c is a split, which is equal to 4. So we can straight away write down our asymptotes, okay? Because we want our asymptotes where x is equal to b, our first one would then be x equals to 2. And then our second one is y equals to c. In other words, y is equal to 4. Because of that, we're going to put them straight into the graph. Sorry, I'm still using my iPad. It'll look a little funny. I apologize. There's x equals to 2. And here is y equals to 4. Once we have those, well, this is a hyperbola. And if we have a look just back on the shape on here, look at the orange lines. Okay, we have one on the top right hand corner and one on the bottom right hand corner. If you have negatives, then they would be on the top left hand corner and the bottom right hand corner. So here's the first bit, and here's the second bit. Notice that the bottom one actually crosses over the x and y axes. You can solve them yourself, but otherwise you should get these particular points here, which is 0 and 3.5, and then on this bit you should have 1 3/4 and 0. A truncus has this particular shape. It looks like a trunk. Okay, notice that this is similar to our hyperbola, in which we have an asymptote at x equals 0 and at y equals 0. Because of that, if we know our general equation, which is this, and as per usual we'll put in our dilation and stuff. I love skipping ahead of time. There you go. And then we have asymptotes, in which we have x equals to b and y equals to c. So let's sketch this graph, where we also need to mention this time the equations of the asymptotes and coordinates. The asymptotes are easy. As per usual, we just write down our b values, and our c values, and there they are. The intercepts we'll have to solve for, in which I'm not going to do in this video. You can solve for them yourself. If you do, you should get these two x-intercepts, and on the top right there's our y-intercept. So, as per usual, put in your asymptotes first. And because we have a truncus, we would have this. Notice that this is positive, so we would have it here. If it's negative, we'll put it on the bottom. And here are our 3 points. Note that when you are doing this, sometimes you will have negative values, so make sure you double check. And I've just noticed a little problem before we finish this video. I forgot to mention our domain and range here. Our domain and range is really dependent on what values we can't have, otherwise we will have every other value there. So this is what you will get. It's listed on yellow on the bottom of the screen. So, just in summary, for the graphs that we have there, okay, A is our dilation, B is our horizontal translation, C is our vertical translation, and the asymptotes are x equals to b and y equals to c.